Ever felt like modern software deployment, especially when Kubernetes enters the chat, is a language you need a Rosetta Stone for? Terms like CI/CD get thrown around, and it's easy to just nod along, hoping you catch the gist. Well, today we're cutting through that noise. This deep dive is all about navigating the landscape of continuous integration and continuous deployment, or CI/CD for short, which is fundamentally about automating your software delivery process for speed and reliability, specifically with Kubernetes, that powerful engine for orchestrating your containerized applications.
That's right. Our mission today is to truly demystify why CI/CD is not just important, but frankly, absolutely vital for Kubernetes. We'll unpack the core challenges it solves and then zero in on how specific, powerful tools like GitOps, ArgoCD, and Skaffold simplify this often complex process. Think of this as your essential shortcut to understanding not just what these tools are, but why they truly matter and how they practically fit into your workflow.
Okay, so we'll start by shining a light on the underlying problems these tools were designed to conquer. Then, we're going to pull back the curtain on each one individually, GitOps, ArgoCD, and Skaffold, exploring what they bring to the table. And finally, we'll reveal how they can actually come together to create a powerful, streamlined workflow that might just change how you think about Kubernetes. Okay, let's unpack this. To truly appreciate these tools, I think we first need to look back at the chaos they were born to conquer. Kubernetes, as we know, is incredibly powerful. It's the engine room for so many modern applications. But let's be honest, it also comes with a reputation for complexity. Trying to manually deploy applications to Kubernetes often feels like trying to assemble IKEA furniture with a blindfold on and no restrictions.
It's a good analogy, actually. Before modern CI/CD practices became widespread for Kubernetes, developers faced significant hurdles that frankly stifled innovation. Imagine the days of manual configuration management. Developers painstakingly writing and applying Kubernetes manifests those YAML configuration files that tell Kubernetes how to run your applications. This wasn't just time-consuming. For complex applications, it was a minefield of potential errors. Really. And that led directly to inconsistent deployments, trying to replicate an application across different environments like dev, staging, or production. It almost invariably led to subtle, infuriating differences because of those manual tweaks. It was that constant battle of works on my machine, but not in prod.
Oh, yeah, I've heard that one before.
Right. Then there were the slow feedback loops. Without automation, the cycle of testing a change, deploying it, and getting feedback just took way too long. Developers were waiting, not coding, which slowed everything down and increased the risk of bugs sneaking into the system.
So if you're dealing with all those manual steps, the inconsistencies, the waiting, how do you even keep track of what's deployed where? What about rolling back if something breaks? That sounds messy.
Exactly. Version control and rollbacks were a nightmare. Without a standardized, automated system, tracking deployment history and reverting to a previous stable version was incredibly difficult. It was like trying to rewind a cassette tape by hand to find a specific song.
Ah, good one.
And the cumulative effect of all this, a serious hit to developer productivity. Developers were spending more time wrestling with Kubernetes deployments and managing resources than actually writing the code that delivered value. It was a major bottleneck in any fast-paced environment.
And that's precisely where CI/CD steps in as the broad solution, automating the building, testing, and deployment of your applications to make software delivery faster, more reliable. But here's where it gets really interesting for Kubernetes. GitOps, ArgoCD, and Skaffold specifically enhance this by providing structured, automated, and genuinely developer-friendly workflows. They make Kubernetes far more accessible.
Absolutely. And that brings us to our first key concept, GitOps. At its core, GitOps is a CI/CD methodology where your Git repositories become the absolute single source of truth for everything related to your application. That means both your application code and your Kubernetes configurations. All changes, whether to the code or the infrastructure, are made exclusively through standard Git commits. Then a specialized tool automatically picks up these changes and syncs them to your cluster.
So essentially, you're saying your infrastructure configuration is treated just like application code living in Git. What's the real game changer there?
Well, the true brilliance of GitOps isn't just that it automates deployments, though it certainly does that well. It's the profound cultural shift it fosters. It makes infrastructure changes collaborative, reviewable, and auditable, just like your application code. It effectively democratizes operations. This means predictable deployments, clear audit trails, and significantly reducing the need for direct, error-prone manual interaction with your Kubernetes cluster. So how does it actually work in practice? Imagine a Git repository storing both your application code and all your Kubernetes manifests those YAML files, right? That define exactly how your deployments and services should run. When you need to make a change, say updating an image version or adding a new service, you do it via a standard git commit and pull request. Normal Git flow. A GitOps tool, like ArgoCD, which we'll talk about, continuously monitors this repository. It constantly compares the desired state defined in Git with the actual state of your Kubernetes cluster. If it detects any differences, maybe someone made a manual change directly on the cluster, or a new version was pushed to Git, it automatically applies changes to the cluster to make them match. This reconciliation means your cluster is always reflecting the truth from Git. The key benefits: robust version control, undeniable audit trails for every change, and incredibly easy rollbacks. Just revert a Git commit. Simple.
That's a fantastic overview of GitOps as a methodology treating your Git repo like the ultimate blueprint for your cluster. Makes sense. Now let's talk about a tool that truly brings that GitOps philosophy to life. ArgoCD.
Right. ArgoCD is an open-source GitOps tool specifically designed for Kubernetes. It automates application deployment by syncing Kubernetes manifest directly from a Git repository to your cluster. It basically ensures your cluster always matches the desired state that's defined and version controlled in Git. What's fascinating here is how it makes GitOps practical and accessible, even if you're newer to Kubernetes. It provides a user-friendly interface.
A UI. That helps.
Exactly, a UI, plus robust automation for managing complex applications, visualizing deployments, tracking all your changes, and handling rollbacks. And all without requiring you to have like super deep Kubernetes expertise from day one.
Okay, so it's the engine that makes the GitOps blueprint a reality on your cluster. How does it manage that continuous syncing without you having to manually trigger things all the time?
Good question. You configure ArgoCD to monitor a specific Git repository, the one containing your Kubernetes manifest, or maybe Helm charts, which help package things up. ArgoCD then constantly compares the desired state from Git with the actual state of your cluster. It's always watching. If any differences are detected, say a new image version has been committed to Git, ArgoCD takes action and applies those changes to your cluster to sync it up. Its key features include both that web UI we mentioned and a command line interface, or CLI, for monitoring. It supports automatic syncing, or you can set it for manual approval of changes if you prefer. And yeah, rolling back is simple. Just point it to a previous Git commit. It also integrates seamlessly with tools like Helm and Kustomize for more advanced configurations. Ultimately, ArgoCD automates those GitOps workflows, dramatically reduces manual Kubernetes operations, and provides a clear visual way to manage deployments.
Okay, so we've seen how GitOps provides the methodology, the philosophy really, and ArgoCD implements it for production-grade deployments. But what about the developer grinding away, writing code every day? How do we give them that same streamlined, almost magical experience? That's precisely where Skaffold enters the picture, right?
Exactly. Skaffold is another open source tool, but its focus is laser sharp on simplifying the development and deployment workflow for Kubernetes applications. It automates building, pushing, and deploying container images and Kubernetes manifests, with a very strong emphasis on improving the developer experience, especially during local development, but also within CI/CD pipelines. Skaffold isn't just a convenience tool, it's kind of a silent enabler of flow state for developers. By collapsing the cognitive load of deployment cycles, that constant build, push, deploy, wait loop, it transforms minutes of context switching into seconds of seamless iteration. You stay immersed in problem solving, not the plumbing.
That sounds like a dream for anyone who's spent way too much time waiting for builds. So what's the secret sauce in the scaffold.yaml file that makes this magic happen?
You define a simple scaffold.yaml file. This file tells Skaffold how to build your container images, maybe using Docker, for example, how to push them to a registry, and how to deploy them to Kubernetes, whether that's with plain kubectl or using Helm or Kustomize. Once configured, Skaffold watches your code for changes. When it detects a change, it automatically rebuilds your images and redeploys them to a local cluster, maybe Minikube or even a remote Kubernetes cluster. Its key features are fantastic. It supports local development, say with Minikube, which is a great way to run a lightweight Kubernetes cluster right on your laptop, and full CI/CD pipelines too. It integrates with Helm and Kustomize, just like ArgoCD, for deploying your manifests. What's particularly powerful is its file syncing capability. This can sometimes update running containers without needing a full image rebuild, dramatically speeding up your feedback loop.
Oh, interesting. So you don't always have to wait for the whole image build.
Exactly, for certain kinds of changes. Yeah. It also includes debugging tools. Skaffold genuinely supports iterative development, making it incredibly easy to test changes rapidly.
Okay, so we've dissected each of these powerful components: GitOps, the philosophy, ArgoCD, its production engine, and Skaffold, the developer's rapid feedback loop. But the real magic happens when they dance together, right? How does that integrated symphony actually play out?
Yeah, if we connect this to the bigger picture, each of these components has a specific role, and they really shine when combined. You'd use GitOps when you want that Git-centric workflow where all configurations are version controlled and auditable. This is ideal when you need consistent, automated deployments across environments, especially in a team that values infrastructure as code and collaboration through pull requests. Think about managing production-grade Kubernetes clusters with multiple complex applications where consistency is absolutely paramount. You'd then use ArgoCD when you're adopting GitOps and need a robust tool to automate the syncing of your Git repositories with your Kubernetes clusters. It's especially useful if you want that clear visual interface to monitor your deployments and manage applications, particularly complex ones using Helm charts or customized configurations. For instance, consider automating the deployment of a microservices-based application with many interconnected components. You really need that single pane of glass for your cluster state. And finally, you'd integrate Skaffold when you're a developer focused on rapid iterative development and testing on Kubernetes.
If you need a fast feedback loop for your local development or within your CI/CD pipelines, whether you're working on simple or complex applications, and you want automated image building and deployment, Skaffold is your go-to. It's perfect for developing a new Kubernetes application locally with frequent code changes, letting you see your modifications live almost instantly.
So how do they actually weave together to create a full, smooth CI/CD pipeline, taking something from a developer's machine all the way to production? Can you maybe walk us through a more detailed scenario?
Absolutely. Let's paint a picture. Imagine a team, let's call them the innovators. Their developer, Sarah, is rapidly iterating on a new feature for their web application. She's using Skaffold locally with Minikube on her laptop. Every time she saves a file, Skaffold detects the change, quickly rebuilds her container image, and redeploys it to her local Minikube cluster, almost instantly. This rapid iteration allows her to test and debug continuously, staying in that flow state we talked about earlier. Once Sarah is happy with the feature and it's thoroughly tested locally, she commits her code changes, which might include any updated Kubernetes manifests that describe her application to the team's shared Git repository. Standard procedure. This is where the GitOps magic, powered by ArgoCD, takes over. ArgoCD, constantly watching that Git repository, detects Sarah's commit. It automatically identifies the differences between what's now in Git, the new desired state, and what's currently deployed in the production cluster, the actual state. ArgoCD then initiates the synchronization, ensuring her production cluster now mirrors the desired state defined in Git.
And, critically, this happens without any manual intervention from an operations person having to run kubectl apply. This entire cycle, from local dev with Skaffold to production deployment via Git and ArgoCD, becomes incredibly smooth, reliable, and auditable. It's truly a seamless handoff.
So just to recap then, GitOps, ArgoCD, and Skaffold aren't just buzzwords. They're powerful concepts and tools that genuinely simplify Kubernetes application management. They shift the paradigm from, manual headaches and inconsistent environments to streamlined, automated workflows, whether you're building locally or deploying to production.
Exactly. They directly solve those initial problems we discussed at the start. GitOps provides that consistent, auditable, and declarative approach to managing your infrastructure via Git. ArgoCD implements that methodology with powerful automation and that user-friendly visual interface, making the declarative approach a practical reality. And Skaffold streamlines the development workflow itself, providing that rapid iteration that keeps developers productive and happy. Together, they effectively tackle manual configuration, eliminate inconsistent deployments, and drastically speed up those slow feedback loops that used to plague Kubernetes development.
The ultimate takeaway for you, the listener, is this. You can absolutely start with Skaffold for your local development and rapid iteration. Get that fast feedback loop going. Then you can adopt GitOps with ArgoCD for your more structured, consistent production deployments. Manage that state declaratively. Combine them, and you've got a robust CI/CD pipeline that makes Kubernetes far more approachable and, dare I say, efficient than you might have imagined.
And here's maybe a final thought to mull over. Given how these tools bring clarity and control to something as complex as Kubernetes deployments using these principles like declarative configuration and continuous reconciliation, how might these very same principles transform other areas of technology, or even maybe project management in the future? What other sources of truth could benefit from such robust, automated syncing and auditing? Something to think about.